Students, welcome back to part 2 of lecture number 15. So, I discussed in the first part the mathematical transformations required for neural network, right. But you can use different kinds of neural networks. The easiest one is to use the completely connected one, where you can see there every node is connected to each one, right. That is what is normally used mostly. You can always use feed forward, which is called directed or acyclic. You can see here the data is going in the right, the transformation is going in this direction, from arrows are like this, right. So, therefore, that is called first feed forward. Each of this network, so this is first layer, input layer, this is your second layer, this is your third layer, and output of each layer used for the input of the other layer in the positive direction, right. It will never come back, or there is no back and forth type of things. You can also have recurrent networks, which is widely used for voice or speech processing, and it has feedback connections, right. So, basically it can come back. So, you can provide the output. So, output is not good, then this second layer can provide a feedback to the first layer, right. So, you can see here input layers. So, they are combined, transformations are done here, then once the outputs are provided to the next layer, they can actually provide a feedback. That means, they can say outputs are not in synchronous with what is their requirement. So, it can again feedback will be given, calculation will be done again further. Okay. That is widely used in speech processing and many other aspects also. So, that is not the one which we will probably discuss in this course. So, you can have different kinds of networks, we have discussed about in the last lecture also. You have feed forward versus recurrent. Feed forward has no loops, inputs, hidden layer, output. Recurrent has feedback loops, right. It can have positive or negative loops. Okay. Many of these recurrent networks are used in NLP also, natural language processing. You can have continuous networks with very small spike rates of firing rate. It is always possible to have spikes which can be integrated over the whole time, and they are very consistent with neural coding also. This happens in case of data transfer in our brain. There is always spike of data, and then there will be always a flash. Then you can also have supervised versus unsupervised. We discussed about it. Supervised networks are like, once we discuss BM or regression or whatever. You can also have unsupervised network like clustering, which we will discuss in the later part of lectures today. So, so you can see here you have multiple inputs and single layer, correct. These are the inputs and this is a single layer. So, these inputs are combined and there are cross sections of different kinds of inputs, the combinations, and then calculations are done in this middle layer and outputs are provided. You can have multiple inputs layer also possible. That is also one of the ways of doing the networks. Okay. So, we are talking about multi-layer. Let us spend some time on multi-layer networks. Whenever we talk about multi-layer, we do not talk about multi-layer neural networks, we talk about multi-layer perceptrons. Please remember this word perceptrons. And we human have a unique ability to identify patterns with certain kind of features, right, with very high accuracy. If we see a bicycle, we can always recognize it as a bicycle. Maybe in your childhood, you have gotten information from your parents that this is how a bicycle look. So, wherever you see, you will know it is a bicycle, right. Similarly, if you see a car in your childhood, you know this is a car, right. So, how do these recognitions happens in our human brain? Because these we learned over the period of time how the objects looks like, right, in 3 dimension, and these are the distinguished features we use to classify them. So, in artificial neural network also we can imitate this human learning capability by putting a very complex architecture, and that architecture much resembles our nervous system, central nervous system, right, which is very, very complex and still not understood. So, one of the ways to do this is to use a perceptron. Perceptron is simply a binary classification algorithm. It was came for Frank Rosenblatt from Cornell in US. It is basically a binary classification 0 or 1, yes or no, right. So, unlike any classification algorithms, this can be model simply by using the neuron, right. neuron has the ability to solve these complex problems. So, why not use perceptrons? It can take few inputs, each has certain weights to signify which is what important or not, and generates output in terms of 0 and 1, correct. So, when you combine such perceptrons, we call it many perceptrons, perceptrons actually we call them as ANN or artificial neural network, right. But neural network itself can be converted to artificial neural network also simply by using different layers. Okay. So, one difference between MLP and neural network is that the classic perceptron model decision function is always step function, remember output is a binary, but in case of neural network decision function can be continuous, it need not be binary. So, that is the difference. Okay. This is the main difference between the MLP and the neural network. In neural networks, the decision functions, function means what? The one which is basically acting on their data, activation functions, they must be, in case of MLP, there must be a step function. Okay. That is why the perceptron model provides output in binaries 0 and 1, yes or no. Neural networks evolves from MLPs obviously, and so therefore, instead of 0 and 1 you can always have outputs continuous, right. So, how does it work? It is very simply, I will talk about step by step also. It takes the inputs, multiply with the weights, compute the sum, add a bias factor, you have seen that, it can be numbers, okay. And this bias factor can be also multiplied with some kind of weights or may not be. Here we have seen in the model I have given, bias factor is W0 is not multiplied by any numbers, okay. It is a separate entity, okay. But it can be also multiplied by weights if required. Biases means what? They are the errors, right. Errors basically we consider errors as absolute change of value from the mean, right. But errors can also vary in a particular experiments. Certain set of data has one kind of error, certain set of data has other kind of errors. So, there you have to use weights. So, these once it is done, that means you multiply with weights, sum it over, add bias, multiply the bias by weights and feed sum the through activation functions. Okay. So, that is how it works. You can see here I already talked about it, I can have inputs multiplied by bias weights added to bias, then first hidden function basically does the activation, produce an output, the outputs again combined with different weights, biases, again activation function is operated on these summed over things and it goes on, first layer, second layer, third layer and finally it provides an output. Okay. That is what happens in a multi-layer networks. Okay. So, this is nothing but a teaming up of perceptrons. You can have different layers stacked together to solve complex problems just now we discussed, okay, what human brain can do. Each perceptron in the first layer, which is the left layer, is basically called a new input layer. It sends the output to all the perceptrons in the second layer, which is nothing but hidden layer, and then second layer sends the output to the final layer, which is nothing but output here shown here. Hidden layers can be as many as hundreds or thousands possible. Okay. Each layer can have a large number of perceptrons, you can see here many large number of perceptrons, and they can be also multi-layer, so that multi-layer perceptrons can quickly become a very complex system. That is how actually these complex systems can be built up one by one. Am I clear? This is how the complex systems are built up one by one. You can have many such perceptrons. Okay. In fact, you can also have perceptrons, some of them may work at a time, some of them may not be work at a time. That means, we can switch off certain number of perceptrons at a particular time and make the others work. Okay. There are a lot of such techniques available. So, in a 3-layer multi-layer, 3-layer MLP, the one shown. So, this is basically called a shallow neural network, because you have only 3 layers, but when you have more than 4 or more layers, it is called a deep neural networks. That is what is used in deep learning methods. You have more such layers are used. Okay. I told you, right, sometimes hundreds of layers are used in case of that. So, let me just explain you again how this multi-layer perceptron works. As you see here, you have inputs, right. So, we can have 1 x1 to xn to xn minus 1 xn, and this is the weights. So, why you are using 1? Because this bias, that this weights W0 is only multiplied by 1. You can see a W0 there, that is why. Okay. That is what is called bias in case of your systems. Now, you can W1 x1, W2 x2 goes up to W1 xn, sum it over activation function, right. So, that is what is done. So, weights represent the relative amounts of each of these inputs. Bias weights basically added and multiplied with constant, sometimes 1, or it can be multiplied with weights also. I have discussed with you also, you have seen that. This is what I wrote in the board also. So, in the step 1, that is what we do, it multiply with weights, and we can simply compute their sum. Neural network algorithms also learn by discovering better and better weights. So, what do you do? These are the weights which are basically optimized, and during the process of calculations, by comparing the output and the actual output and the calculated output. Calculated output and actual output are compared, and these weights are then found out. How they do? They are done by backpropagation network, which we will discuss after a couple of slides. So, we always add bias factor and sometime multiplied by weights. This is a technical step, because it makes possible to move activation functions curve up and down, left and right on the number curve. Okay, you understand that activation functions can be move up and down or sidewise based on what kind of bias you are putting on your systems. Correct. That is one of the ways bias can do. It also makes us possible to fine tune the numerical outputs of the perceptron. Remember this, because bias factor is very important in all the neural networks. The selection of bias is also another variable. Then we actually, once we get all the biases, everything, we can use activation functions and provide the values. Like, let us say input values could be between 100, output can be 0 and 1. So, activation function helps in perceptron to learn the things, and when it is a part of multi-layer perceptron network. Okay, so, let me also tell you that the perceptron output is a classification decision, it can be 0 or 1. Okay. What is this different kind of transformation we do? You have to find out these biases as well as weight factors. So, classical perceptron to full-fledged deep neural network, that is what we have seen, and there are 3 different types of processing we can do. One is called backpropagation, then hyperparameters tuning, and third one is called advanced structures. Okay. So, what is backpropagation? It is basically an algorithm which allows you to perform backward passes. Okay. So, let me go and tell you that in football, many times what happens, if you instead of playing in the forward passes, the ball is sent to the back. Okay. And you can see here this player, the player here actually. So, it is basically instead of sending this pass here, so that this fellow can score the goal, he actually pushes here, and then it forwards this here, and it makes a goal, right. So, this is called the backpropagation. So, in backpropagation you can always make a backward pass. Why you make the backward pass? That means you make the calculation going back to the earlier layer. That is what is called backward pass is, and it helps you to fine tune these weight factors, biases as well as weight factors. There are so many weight factors are there, these Wij's, okay, and these biases, they need to be optimized. So, they can only be optimized when we can do a backpropagation. We can go back to the last layer which you have handled it and fine tune these parameters. Okay. So, you can see in the next layer also we have certain kind of weights and biases, they also needs to be optimized. That is why the backpropagation things works nicely. It is basically iterative backward process. Idea is to attempt to minimize the loss function, minimize the error or loss functions, and that is nothing but difference between the correct prediction and the actual model prediction. So, many of these things which you handle, many of the kind of real life problem which you handle may have an actual output. So, we compare the actual output with the model output, and if we see there is no, they are not matching, or we calculate the error between these two, and that is what is called loss functions. So, idea of backpropagation is to minimize the loss functions. We discuss about it in the several other networks also, several other problems also. So, each backward pass weights will move towards an optimum value that can minimize the loss functions, and that can lead to more accurate prediction. That is the idea is. So, you always calculate the loss function each layer, and once you calculate loss function, you know what is the error in W's, both in case of multiplying factors to the inputs as well as biases. So, both needs to be optimized. That is why it becomes a very complex network. So, when the neural network is initialized, weights are always set to whatever is individual values, and then these weights are changed, okay, or weights are optimized based on backpropagation networks. So, backpropagation basically helps you to adjust the weights of the neurons. So, results become as close as the actual values. That is the idea. So, and this backpropagation is widely used. In fact, hyperparameter tuning is also similar like backpropagations, but a little bit different than the backpropagation in terms of using how do you tune the parameters. So, we will discuss the hyperparameter tuning in some other lectures when we come back. It is used in many such machine learning algorithms. Okay. So, backpropagation algorithm allows you to perform backward passes, which is basically helping you to tune the weights in a nutshell, and it perform iterative backward passes, back and forth, back and forth, back and forth many times, so that the loss functions can be minimized. Okay. And when you do each time backward pass, weights will move towards an optimum value. That means, weights will be changed and this is what the intelligent guesswork is important in case of neural networks. Many people call this as actually a black box kind of things. So, in a sense, these weights what you see here, this all these weights W0 to W1, W n minus 1 Wn, they needs to be optimized. That is what is the final idea. So, I will not discuss much about this. There are many other things which could have been discussed. So, let me whatever time I have, let me just introduce the concept of clustering. This is a part of unsupervised learning, remember that. In case of unsupervised learning, we do not have both the input value as well as levels of the outputs, right, that is what. So, in case of supervised learning, you have both, so we can handle it very nicely, but in unsupervised learning, we do not have. So, that is why unsupervised learning can only group or interpret data based on only inputs. It can group, it cannot actually compare the what is the input and output correlation, because output does not exist, okay, like in case of supervised learning. So, what do you do? There are different types of clustering possible. You can group the data. You can have K-means clustering, hierarchical clusterings, you can have PCAs, principal component analysis, ICA, independent component analysis, you can have singular value decomposition, a priori algorithms, also anomaly detection possible. Okay. So, we will not talk all these aspects, it is not possible even discuss everything in a class. So, we will talk about K-mean clustering. So, what is basically a clustering? It is nothing but a grouping data based on certain similarity in a very rudimentary way, right. We should group the data based on certain similarity with each other, that is what is called a cluster analysis. Many of you must have used this technique for your own researchers or in your some courses also. This method is obviously unsupervised learning, and it tries to get insight from this unlabeled data points what kind of relationship exists. As I say unlabeled, so labeled data points will have input and output both. Unlabeled will have either this or this, most of the cases you have this one, you do not have y, right. So, we are using only x data. So, when you plot it, our idea is to forming groups of homogeneous data from a heterogeneous data sets, because it can allow us to find out similarities and based on a matrix like other Euclidean distance, cosine similarity, Manhattan distance, many other things. Euclidean distance right, R is basically root over x1 minus x2 whole square plus y1 minus y2 whole square, right. That is what is called Euclidean distance is, right. So, if in coordinate geometry this is widely used, if I have two data points, one here, this is x1 y1, x2 y2. So, I can find the distance between these two by using this formula. Manhattan distance is different. We will talk about all these things in the next lecture, how the Manhattan distance are calculated. So, we can actually calculate, we can actually find out these similar groups based on the matrix like a Euclidean distance or Manhattan distance. Okay. So, in a nutshell, dividing data into meaningful groups based on informations of the data sets, and this grouping points is done based on similarity. So, you can have either centroid models or connectivity models or density based models. Centroid model is what is called a K-means algorithm, connectivity model is called hierarchical clusterings, and density based models are basically called partial clustering with application of some noise, right. This is called partial clustering. The three different types of clustering exist. One is called centroid clustering model, what is called K-means algorithm, which is very famous in machine learning. You can also have used connectivity models like hierarchical clusterings or density based clustering. So, let me just give you an example. Let us say you have a dense dysentery outbreak in Delhi, and somebody is trying to plot these dysentery outbreaks on a map. So, you can clearly see these data are clustered around certain regions, right. You can see that. So, this means what? That the reason for dysentery outbreak is maybe related to some polluted wells, which is causing this bacteria for dysentery to be exposed to the human, and so therefore, we can actually work on it nicely. We can improve the water quality and take care of the dysentery problem, right. You can also have this kind of data, and you can make groups. See, I have made 6 groups, you can make even more than that also. Can you see that? There are about 11 groups possible, so instead of 6. So, how you do this? How do you know how many clusters exist, or how can actually decide on the clusters? That is what is the algorithms, we will talk about it. Okay. So, you can have 2 types of algorithms, mostly one is called flat algorithm. You can start with any random partitioning of data, any kind of random, and then do a iterative process to find out the best clustering or best cluster. Okay. That is what is called flat algorithm. You do not have to worry about any kind of a priori or biasness. You can start with a random partitioning, and these are all K-means clustering. In hierarchical clustering, you can have bottom up or agglomerative approach or top down divisive. Top down is obviously divisive approach, but you can also have start with a small one cluster and then one data point, and then put them together one by one and try to make a agglomerate. Otherwise, you can have all the points in one cluster and divide them. This is called top down approach. Okay. So, there are other type of clustering also like hard or soft. In hard clustering, each data point belong to a cluster completely or not. Remember that. So, for example, let us say there are 4 data points, we have to cluster into 2 different clusters. So, each data points will either belong to cluster 1 or cluster 2, they cannot belong to both the clusters. But in soft clustering, this assumption is relaxed. Instead of assigning each data points to a separate cluster, we can also have a probability or likelihood of a point being part of a cluster, right. We do not do that. We do not assign each data point to particular clusters, but we calculate the probability or likelihood of the clusters or the point belonging to the particular clusters. So, if you have 4 data points, we have to cluster in 2 clusters. So, we will be evaluating probability of each data points to belong to both of the clusters. So, we do not earmark the clusters nicely, we only calculate the probability and say this much probability exists for these points to belong to cluster number 1 or cluster number 2 or cluster number whatever. Okay. So, what is the concept actually? So, basically given a classified objects, a means of measuring the similarity of the objects is what is used in terms of distance matrix, and objects of such some standard of quality is met, like maximize the similarity or or discover some kind of symmetry of the data. But ideally speaking, we would like to represent clusters and the semantic explanation very differently way, like we like to define clusters as a extensionally or by some general rules, not by some enumeration, not by certain numbers. That is not done here, remember, that is nothing but a dream kind of things. So, what happened in centroid clusterings? We guess a centroid. Okay, let me go back to that, or I do not have that, I will talk about it in the next class. So, we basically guess a centroid of each cluster point, center point, assign the point to the nearest to the centroids. That is what we do. So, let us stop here. Actually, we will come back because I need to show some pictures, and I need to also discuss some mathematical viewpoints to explain how the clustering works. So, at this moment, this is the introduction of the clustering. We will discuss more in the lecture number 16, and give you a better perspectives. Thank you.